This next video lesson is going to cover how to do math and round your answer when you're dealing with numbers involving different significant figures. In our class, there's basically two types of calculations that you're going to encounter. You're going to encounter addition/subtraction questions, and you're going to cover multiplication and division questions. And you want to treat each type differently because they round their answers slightly differently. So you encounter a problem where you're going to do some math. You're going to multiply some numbers together. You're going to add some numbers together involving significant figures. You first do the math in your calculator. You have the entire number and you round your answer off. But you're going to round your answer treating adding and subtracting problems differently than multiplying and dividing problems. I'm going to talk about the rules for add-subtract first. This is the lesser used of the two types. Add-subtract happens less often, maybe 30 to 40% of the time. Multiply and divide will happen most likely, but I'll start with add-subtract. Now when it comes to adding and subtracting, it's really nice if you stack the numbers on top of each other and add them together like you learned how to do in elementary school. For example, if you have 30.0 and add 27.1. Now the answer is going to be 175, drop the decimal point, 57.1. Now, this number actually doesn't need to be rounded because in adding and subtracting, you round your answer based on the least precise place value of the numbers you added together. Now, the place values get more precise the further to the right you go. So if you go 2 past the decimal or 3 past the decimal or 4 past the decimal, you get more and more precise place values. Precise means exact, so you're getting more exact numbers. But since both of these numbers both end in the tenths place, then you report your answer to the tenths place. So this one doesn't actually need to be rounded. But I'm going to set this one up next to a number that may need to be rounded. So I take 30.0 again and I add 1.75. And if I add from the right to the left, now I want to put a 0 in here, but I don't because it's not there. This is a measurement and the 0 doesn't exist. And so there is a 0 there, but you'd add 0 plus 5 is 5, 0 plus 7 is 7, and 0 plus 1 is 1, and 3 plus 0 is 3. So your answer is 31.75. Now you go back and look at your numbers you added together, and you pick the least precise value, meaning the least precise place value. The first number goes 1 past the decimal, where the second one goes 2 past. Now going back up to the rule, you round based on the least precise place value. So what I'd like to do is I draw a dotted line after the least precise number. It might be the first number, it might be the second number, but the first number in this case is the one that goes the least number of digits past the decimal. And I drop that vertically, and then I think to myself, okay, I need to round this last number, the one that is right before the dotted line. Now I'm going to round it based on your normal rounding rules. If the 7 is followed by a 5 or higher, it rounds up, and if it's followed by a 4 or lower, it stays the same. So I need to take my answer now, and I round it to 31.8 because the 5 rounds the 7 up to an 8. And then you drop all place values after that. This is my final answer, 31.8. So in summary, when you add numbers of differing place values, you round based on the least precise place value of the numbers added together. And that includes if you add 3 numbers or 4 numbers or 5 numbers together, you always round based on the least precise number. So as you see, these are all addition and subtraction problems, and we're just going to perform the math and then round these off to the proper number of place values based on the numbers that I added or subtracted together. So this first one is 1.680 plus 27, and that equals 28.68. At least that's what the calculator will tell us. But since my numbers, the first number goes 3 past the decimal and my other number goes just right up to the decimal, I need to round my answer right up to the decimal. And so since the 8 is followed by a 6, it rounds up. So my rounded answer is 29. And that is the proper number rounded to the correct number of significant figures. Now this next one, 14.9 subtract 2, is 12.9. Now again, I look at the precision or the exactness of the place values. This one goes 1 past the decimal, and this one goes up to the decimal, but not past. So I need to round my answer up to the decimal, but not past. So I think to myself, all right, 2 is followed by a 9, so that's going to round up. So that becomes 13. The next one, I add 18.784 plus 0.03, and that equals 18.814. Now I double check my place values. This goes 3 past the decimal and this goes 2 past the decimal. So I go 2 past the decimal and I drop a line and say, okay, the 1 is the one that needs to get rounded. And it's followed by a 4, so it stays the same. So I figure out that this answer is 18.81. Now if this number was a 5 or greater, this number would round up. But since it's a 4, it just drops off, stays the same, and you drop off the ending numbers. Now this last one, 37.8 minus 2.0 is 35.8. And since both of them go 1 past the decimal, my answer goes 1 past the decimal, it's all done. We don't need to round it. In fact, that's the best case scenario when both your numbers go to 1 past the decimal and your answer likewise is 1 past the decimal. So now we've covered and did some examples of addition and subtraction, and remember that's based on the place value. Now we're going to talk about multiplication division. And it's important to note that this is the most likely scenario that you're going to encounter in chemistry class. We're going to do a lot of multiplying and dividing and less adding and subtracting, but adding and subtracting shows up every once in a while. So pay close attention to this next slide. So for multiply and divide, you start off by doing the math in your calculator and you hit enter. And then you're going to round your answer. But instead of rounding based on the place value, multiply and divide rounds on base of lowest number of significant figures. So once you round your answer to the same as the least number of significant figures of the numbers in your problem, you will have your correct answer. Now this is why it was so important that on a previous day or in a previous video lesson that we talked about identifying the number of sig figs in the problem, because now once you've identified the sig figs of the numbers that you multiply or divide, then you round your answer based on the lowest number. And here's an example. I take 27.5 times 3 plus 4, the calculator tells me the answer is 93.5. But if I go back and look at the problem, this first number had 3 significant figures and this number had 2. So my answer cannot be more significant figures than my least number in the problem. And so if this is 3 and this is 2, my answer has to be rounded to the lowest number of significant figures of the two numbers I multiplied together. So I, again, pick the significant figures starting from the left. This is the first, this is the second, and I'm going to round right here. So 93.5, the 5 rounds the 93 up to 94. But if it was 95.4, then I would just round it down to 94 and drop off the remaining numbers. So here's another example. I'm going to take 110.5 times 24, and the answer is 2652. Now I need to round this answer based on 2 significant figures because this number has 4 sig figs and this number has 2. So I'm going to round at the 26. So my answer is going to be rounded. So 2652 rounds up to 2700. So basically I take the 6, and since it's followed by a 5, it rounds up. So I put the 27, and then I put zeros in these 2 spots as placeholders. Because you don't want to just round 2652 off to 27, because the 2 needs to stay in the thousands place and the 7 needs to stay in the hundreds place, and you're just going to put zeros in as placeholders in the tens and ones place accordingly. So you don't round your answer off to 2 digits, you round your answer out to 2 significant figures. The number should still have the same number of digits as your original number, just it may have zeros in those placeholders. Now it's important that you don't put a decimal point in because that makes those zeros significant. So you definitely don't want to do that. You just simply put in zeros as placeholders. So let's do the math of these ones. The first one, 1.680 times 27. That's going to be equal to 45.36. Now I take a look at the 2 numbers, and my second number is only 2 significant figures. So I'm going to round off to 2 sig figs. 45.3 stays just 45. And I don't add a 0.0. I don't want to do that because that's a significant figure. If this number was really, really big, I'd put a 0 in as a placeholder. But in this case, you don't add 0.0. You just simply say 45 because you only want it to be 2 sig figs. This next one is 14.9 divided by 2 is 7.45. Now again, I round my answer based on the lowest number of significant figures. This is 3, that's only 1. So my answer rounds after the first sig fig. 7.4 just rounds down to 7, and that's my final answer. So I'll circle the answers here. This next one, 18.784 divided by 0.03 gives me 626.133 repeated. But my answer needs to reflect the significant figures of the problem. This one goes out to 5. This one only has one significant figure. Remember, these zeros are not significant because they come at the beginning of the number, not at the end. So my answer can only have one sig fig. So the first sig fig is 600, and it stays the same since it's followed by a 2. And then I put zeros in for the 2 and the 6 as placeholders, because the 6 needs to stay in the 100 spot, and then these zeros go in the tens and 1 spot respectively. So my final answer is 600. Finally, 37.8 times 2.0 gives me 75.6, and I need to round my answer to 2 sig figs. This is 3, this is 2. Now in all these examples, I've always rounded it based on the sig figs of the second number, but that's not always the case. If the first number has lower significant figures, then that's the one you round your answer based off of. So 75.6 rounds up at the 5 to 76. And that's my final answer, because that's an answer reported to 2 significant figures. So this is how you perform math and round your answers. Remember, adding and subtracting is different than multiply and divide. I hope you enjoyed this. Thanks for listening.